the length of the cross product of this vector that is in standard unit vector notation and this other vector, well, can I first put this into component form? 2 will be in the first component, negative 2, negative 1 in the next component, cross, okay, if 1 in the first component, 1 goes with I hat, OK is the third thing, so negative 1 for the third component, and 0, since there's no j, I guess we have 0 times j there. Before I can figure out the length of that thing, I better figure out what the components of it are. Off in the corner, perhaps down here, I can use that trick where I say I hat, j hat, k hat, and 2, negative 2, negative 1, 1, 0, negative 1. And the way I usually do this is I think the I component comes from ignoring the column with an I in it and the row with an I in it and just looking at this, and it's negative 2 times negative 1, which is 2, so negative 2 times negative 1, and then minus, okay, so negative 2 times negative 1 minus 0 times, oh, whatever, 0 times, dang it, okay. Then the next thing, you do the usual stuff with that. There's an extra minus sign, and the extra minus sign is attached to 2 times negative 1, negative 2. So here I'm looking at the 2 by 2 matrix obtained by ignoring the row with j in it and the column with j in it, so I've got a 2 and a negative 1. And I've multiplied those, and I subtract from that 1 times negative 1, which subtracting negative 1 means adding 1. And in the last component, I look at k hat, I delete its row and column, I get 2, 0, so that's 0, minus 1 times negative 2, 1 times negative 2 is negative 2, so I'd be adding 2. Okay, so I should say that this cross product is equal to 2 in the first component, and here 1 minus 2, that's negative 1 with a negative sign, so that's positive 1. Last component was just 2, is 2 squared plus 1 squared plus 2 squared, which is, let's see, 4, 6, 7, 8, 9, square root of 9, oh, but that's 3. And so the object I'm talking about is the cross product here. Its direction is, the direction is always 1 over the magnitude, 1 over 3, times the vector, 2, 1, 2. And what am I meant to do? Let me look at my instructions. Find the length and direction of, oh, I'm done. Okay, good. And I'm also asked to find the length and direction of the cross product in the other direction. So that is to say, swap these two terms. So the length of, let's see, I hat minus k hat, I'm going to be reversing these guys, cross 2i minus 2j minus k, which is simply negative. So look, when you switch the order of the things you're taking the cross product of, you get a negative sign. So this will be negative 2, 1, 2 is 3, and now this sentence has that cross product as the subject and its direction. I'm getting dangerously close to this scratch works, let me put that over here, box, is, okay, so its direction is 1 over the magnitude times the vector itself. I can just do it this way this time. Negative 2/3, negative 1/3, and negative 2/3. Right, so here I've just used the property that U cross V is negative V cross U. And that comes from the right-hand rule. Right, we obtain the direction for V cross U by going along the direction of the first curling into the direction of the second. And so if we swap the order of the two things we're taking the cross product of, we get a negative sign.